Okay, so today we're going to go on to Chapter 3, Section 6. It's the last, or excuse me, Chapter 3, Section 7, Real World Problems. It's the last section in Chapter 3, and it's pretty similar to Chapter 3, 6. It's more word problems. These are just considered real world problems. So, students will be able to solve real world problems by algebraic reasoning. So you have used models, diagrams, and tables to translate verbal descriptions into algebraic expressions. When solving problems algebraically, you can use mental pictures to guide you. Okay, so problem number 1, right here where we start with Donovan. Okay, so we're right here. Sorry about that, right there. So after Donovan gives Mabel 6 pairs, she has x plus 6 pairs. If Mabel gives 1/3 of her pairs to Nelson, how many pairs in terms of x does Nelson have? Okay, so x plus 6 is what we're starting with, and she's giving 1/3 to Nelson. So 1/3 of x plus 6. So of means multiply, so you have 1/3 times the quantity x plus 6. We also have a picture of a bar diagram up here of the same thing. Okay, so now we have to distribute. 1/3 of x is 1/3 x, 1/3 of 6 is 2, so my answer is Nelson has 1/3 x plus 2, and make sure since it's a word problem you put a unit, it would be pairs. Okay, so let's go on to the next one. Here's number 2 right here. Okay, there are n apples in a box, but 5 apples are too green to eat. Aaron and Barry share the ripe apples at a ratio of 2 to 3. That means Aaron gets 2 for every 3 that Barry gets, because it says Aaron and Barry 2 to 3. Okay, how many ripe apples does Barry get? Okay, so we can do this with a bar model if we want to. So if we think of it, we have n apples and 5 are too green. So n minus 5 is the ripe apples, and then we have the 5 green apples over here. Now it says Aaron and Barry share them at a ratio of 2 to 3. So that means out of 5, we break this into 5 equal pieces, because 2 plus 3 equals 5. So that means 2 pieces go to Aaron and 3 pieces go to Barry. Okay, so now it says, how many ripe apples does Barry get? Okay, well, Barry's share is 3 out of the total. We have 5 total apples, so 3/5 of n minus 5. Sorry, I need to make that a minus. Okay, so 3/5 of n minus 5. Okay, so now we need to distribute. So 3/5 of n is 3/5 n, and 3/5 times negative 5. Okay, so 3/5 of negative 5, here's my work right here. The 5s are going to cross cancel, and you're going to get negative 3. So your answer is Barry will get 3/5 n minus 3 ripe apples. Okay. All right, so now it says method 2 is algebraically. So only ripe apples are shared, so you subtract 5 green apples from n apples. So that's where the n minus 5 comes in. So the number of ripe apples is n minus 5. Now, Aaron's apples is 2, Barry's apples are 3, so Barry gets 3 out of every 5 apples because 2 plus 3 is 5. So the number of ripe apples Barry gets, he gets 3 out of 5 times the quantity n minus 5. So it's the same thing we just had, just writing it algebraically and not with a picture. Okay, so let's go down to this one, the area of a triangle. Okay, so the area of a triangle is u plus 10 square centimeters. The ratio of the area of the unshaded, so 1 equals unshaded and 3 equals shaded. Okay, so unshaded is 1, shaded is 3. Use algebraic reasoning, express the area of the shaded region in terms of u. Okay, so then the area of the shaded region is 3 out of the total, which is 4, because 1 plus 3 is 4. So 3/4 of u plus 10, because there's the u plus 10 right there. Okay, and if you look at the picture here, 3 out of 4 pieces are shaded, u plus 10. Okay, so then we need to distribute. So 3/4 of u is 3/4 u. 3/4 of 10 is 30/4, which is 15 halves centimeters. So that's your answer, 3/4 U plus 15/2 centimeters. Okay, now we move on. One number is n, a second number is 2n divided by 3 plus 2. A third number is n over 6 less than the second number. Express the sum of the three numbers in terms of n. So sum means answer to an addition problem. Okay? So when we're adding or finding the sum, we add the numbers together. So the first number, one number is n. The second number is 2n over 3 plus 2. And the third number is n over 6 less the second number. So if you look here, I have the second number minus n minus 6. Because remember, more than, less than, added to, and subtracted from. Those are the statements that move it to the end. You have to move it to the end. That's why n divided by 3 is at the end. So now we combine our like terms. Okay, so we have an n and a 2/3 n and a 2/3 n and a minus 1/6 n. And you need to find a common denominator. So your common denominator is 6. So we have 6 over 6n, which is equal to n. We have 2/3 n, which is equal to 4/6 n. Again, 2/3 n is equal to 4/6 n, and then the negative 1/6 n stays. So 6 plus 6 is 10, plus 4 is 14, minus 1 is where the 13/6 n comes in. And then we have a positive 2 and a positive 2, which is 4. So your answer is 13 over 6n plus 4 is the sum of the three numbers in terms of n. All right. So there are an equal number of boys and girls in a group of 80 children. Within the group, P% of boys and Q% of girls wear glasses. Write an algebraic expression for the number of children who do not wear glasses. Factor any terms with a common factor. Okay, so that's one we haven't seen before. Factor any terms with a common factor. All right, so that's the end of the... Okay, so the number of boys, it says, is equal to the number of girls. Okay, so the number of boys equals the number of girls. All right, and it told us that there are 80 children together. So if the boys and girls are equal, 80 divided by 2 is 40. Okay? So we have P%, P divided by 100 is 0.01 P because, and Q% is Q divided by 100, which is 0.01 Q. Now, we know the number of boys is 40 and the number of girls is 40. So we do 0.01 P times 40, that's 4/10 P. 0.01 Q times 40 is 4/10 Q. Now, the number of children who do not wear glasses is that's the number who wear glasses, minus 80, because 80 is our total. So that's where the 80 minus 0.4 P minus 0.4 Q come in. All right, so then what you have to do is they have us factor. So negative 0.4 comes out of both of those. So here we have 80 plus, we're distributing out the 0.4, so negative 0.4, and then we just have P plus Q. And that's your answer. The number of children who do not wear glasses is 80 plus negative 0.4 times the quantity P plus Q, and you leave it just like that. Okay, now I'm going to read the next one to you, and then I'm going to give you some time to try it on your own. It says a shoe store stocks X pairs of sneakers and Y pairs of sandals. During a promotion, a pair of sneakers is priced at $50 and a pair of sandals at $36. The shop manages to sell half the sneakers and 80% of the sandals. Write an expression for the total amount of sales the store makes. So I'm just going to give you one hint. If I were you, I'd set up a table with sneakers, and I'd write everything I know about the sneakers, and then I'd set everything with the sandals, and then that'll help you. So I'll come back on in a minute. Okay, so if you're stuck, I'm just going to give you a hint. The first thing I did is I wrote down all the information I got out of the problem. Okay, so it says the store stocks X pairs of sneakers, so I put an X under sneakers, Y pair of sandals, so I put a Y under sandals. During a promotion, a pair of sneakers is $50, so I put 50 under sneakers, and sandals are $36, so I put 36 under sandals. Then it says the shop manages to sell half the sneakers, so I put a half under the sneakers, and 80% of sandals, so I put 80% under the sandals. Okay, and now it says write an expression for the total amount of sales the store makes. So if I'm total sales, that means when I'm done with this, I'm gonna add the stuff together. Okay, so go ahead and try to figure it out from there. Okay, so what I know about sneakers is you're taking 1/2 of 50x, 1/2 of 50x, and for the sandals, 80% of 36y. Remember, to turn a percent into a decimal, we need to move the decimal point 2 places to the right. So 80% is equal to 0.80. Okay? So now, half of 50x, half of 50 is 25, and 8.8 times 36, here's my work right here, I get 28.8. So 25x plus 28.8y dollars is your final answer. Okay, so have a good afternoon, and I'll see you tomorrow.